So on page 207, we're going to start talking about what we're going to do with those fundamental identities. There's a large green box, and it says hints. Hints for verifying identities. Will you start reading? Who wants to start? Go ahead, Cindy.
Me. I will read.
See, Cindy started first.
Learn the fundamental identity. No, I started. See.
Learn the fundamental identities given in section 5.1. Whenever you see either side of a fundamental identity, the other side should come to mind. Also, be aware of equivalent forms of the fundamental identities. For example, sine squared theta equals 1 minus cosine squared theta. It's an alternative form of the identity sine squared theta plus cosine squared theta equals 1.
So we talked about those. When they say learn the fundamental identities, what did we do?
Oh no.
Wrote them on the back of our plate, so they're with us always.
So one's already done.
Yes, one is done, but recognizing, like we talked about the other day, being able to write sine squared theta equals 1 minus cosine squared.
You have another plate I can make.
Yes. Number 2. Landry, will you read number 2?
Sure thing. Try to rewrite the more complicated side of the equation so that it is identical to the simpler side.
Alright, so we're going to distinguish which side of the equation is more complicated. And we're going to work with that side. Okay? Number 3. Go ahead, Ireland.
It is sometimes helpful to express all trigonometric functions in the equations of terms of sine and cosine and then simplify the result.
So generally, after we've decided which one side is more complicated, we're going to try to write the whole thing in terms of sine and cosine. Okay? We're on page 207. Number 4. Who wants to read number 4?
I'll read it. Is it just the bold, or you want me to read the whole?
You can just read the bold.
Usually, any factoring or indicated algebraic operations should be performed.
So,
Go ahead.
go ahead.
This expression.
So this expression. So do we have to remember algebra stuff?
Yes.
So when you see sine squared theta plus 2 sine theta plus 1. You know that you can factor it. Sometimes I will give you hints and say, hey, what about x squared plus 2x plus 1? Can you factor that? And your x is simply sine theta. Okay? So can we factor it? They walk you through it. Of course you can factor it. This would be x plus 1 and x plus 1, correct?
Oh man, I haven't factored in a while.
It's been a while. We're going to have to start factoring a little bit. Sometimes we'll just factor something out. Okay? Ooh, the sum and difference of 2 trig expressions. 1 over sine theta plus 1 over cosine theta can be added or subtracted.
I was stretching.
Another problem. What about 1 over sine theta plus 1 over cosine theta? How do you add fractions with different denominators?
Make my same denominator.
You have to have common denominators. So I'd say what's 1/3 plus 1/5? Did we talk about this one the other day? I feel like we did.
Yeah.
So we would have to multiply this side by what?
By cosine.
By
Over cosine over cosine.
Cosine over cosine.
And the other one? By sine over sine.
By sine over sine.
Thank you.
Okay? So that we would end with what?
Cosine theta over cosine theta sine theta. And then sine theta over cosine theta sine theta. No.
Okay, does it matter that I wrote cosine? In all seriousness, does it really matter? No. But when they have common denominators, what can you do with the numerator?
Add them together.
Cosine theta plus sine theta all over.
Cosine theta sine theta. I like saying that. Cosine theta sine theta. Cosine theta sine theta.
I'm so happy. Yeah. So writing, getting common denominators, and adding fractions together, that's a good thing. Number 5. Who wants to read number 5? Go ahead, Mackin.
As you select substitutions, keep in mind the side you are not changing because it represents your goal. For example, to verify the identity.
Yes. Tan squared x plus 1 equals 1 over cosine squared x. Yes. Try to think of an identity.
The one kid just picked up a huge piece of icing and looked at it, and I think around here.
Real
The
kids.
kindergartners.
It would make their day. Probably their year.
Big seniors going on.
Seniors,
Takes a snowball and
kids.
chucks it out.
This is, but they're already going in.
Oh, nice.
Yes,
Yeah,
yes,
they-
they are. They're
No,
wiping their
not.
feet off. Let's play.
Exactly. We have time.
Let's do it.
Let's do it.
We are recording this.
Let's do it. There, now they can hear.
Hit it.
What?
Hit it.
Get it. Get it. Get it. Cosa interesante.
Alright.
Cosa interesante.
Try to think of an identity that relates tangent to cosine. So in the middle of number 5.
If none of the kids come out, can we go with them?
So, can I say, number 5, would we write tan squared theta in terms of sine and cosine first? Alright, let's talk about what does it mean to verify?
Well, like on TikTok. If you're good on
You're going to
TikTok,
confirm
you're
something.
verified.
Confirm that you're
That tells me nothing.
You think she has Tic Tac? Tic Tac. My mom has Tic Tac. She sent me a couple. I was like, why are you on Tic Tac?
It's
My dad
not
has it.
TikTok.
Okay.
This is for New Yorkers. Tic Tac.
So, one of the things said rewrite in terms of sine and cosine. To verify this, we're going to make sure that the left side actually equals the right side. That's going to be verifying. We will not work with both sides. We will not do things like add the same thing to both sides or take the square root of both sides. We won't do stuff like that.
Why not?
Because we just want to verify that the right side equals the left side. And the left side equals the right side. So we're going to make a determination. Which side is more complicated, and that's the only side we're going to work with.
You're gonna work with the more complicated stuff.
Because we want to make it simpler.
Uh,
Okay? It also has the statement of, we're going to rewrite in terms of sine and cosine. Okay? But in this case, do I want to take tan squared theta, tan squared x, and rewrite as sine squared over cosine squared? No, we don't. But do you see tan squared plus 1 somewhere on the back of your plate?
Yes.
Where does tan squared theta plus 1?
Pythagorean identity.
It's a Pythagorean identity, and what does it equal?
Secant squared.
So anywhere you see this, what can you write?
Secant squared.
Secant squared theta. Is somewhere else on near the back of your plate something that says secant theta?
Secant theta equals 1 over cosine.
Okay, so in my thought bubble, if I have secant theta equals 1 over cosine
That's just
theta,
2 of them.
can I square both sides? Is secant squared the same thing as cosine squared?
Yes.
Equal to 1 over cosine squared. I mean, could I even say 1 squared if I square both sides? If I squared everything. Yes, but it's still 1. So can we rewrite secant squared now in terms of cosine?
Yes.
Yes, so it's what?
1 over cosine.
Squared. And when the left side equals the right side now, I'm going to draw an arrow. I'm going to put a check mark. I'm done. We have verified
Oh.
that the left side equals the right side. It's pretty easy. Okay? Usually the question I get is,
It's kind of like backwards.
it's kind of like working your way backwards.
So you
I
just
know
have to
what
pick
it-
which one.
I know what it has to equal. Can I write? That's why the complicated side's more, it's smarter, it's easier to start with because you have more ways to go. Okay, if it's already very simplified, trying to make it complicated is really hard. It's generally really hard. Okay? So last one, number 6. Lorenzo, can you read number 6 for us?
If an expression contains 1 plus sine x, multiplying both numerators and denominator by 1 negative sine x would give 1 negative sine x squared, sine squared x, which could be replaced with cosine squared x. Similar results for 1 negative sine x plus 1 cosine x and 1 negative cosine x may be useful.
Okay. So sometimes in algebra it was conjugating. If you were left with 1 over 1 minus sine x, could I multiply the top and the bottom by 1 plus sine x?
Well, you can do it. I mean,
You can do it if you
anything
want,
that
because
works,
1 plus sine x over 1 plus sine x is just what?
1.
1. You can always multiply by 1. Okay? So when I multiply, what do we get on the top? 1 plus.
Sine x.
On the bottom, do I have to FOIL?
Yes.
Yes, I do. So 1 times 1 is 1. 1 times negative sine is
Negative sine x.
negative sine x. Inside, I have a plus sine x. And then the outside, or the
Negative
last.
sine
Squared.
negative sine squared. Does anything in the denominator cancel?
Yeah.
Yeah.
Negative sign and a positive sign, what are we left with?
1 minus sine.
Question.
We have 1 plus sine x
Why?
over 1
Four.
minus sine squared x.
Question.
Yes.
How can you cancel a negative and a minus sign?
There's a negative sine x
Yes.
and a positive sine x.
Let's turn.
So what's negative 2 plus 2? Okay. We do this thing right here where we pick the opposites
Plus,
because the middle term will always cancel. Okay. Going backwards from the difference of squares. Do you remember the difference of squares?
Probably not.
Probably not. Difference of squares, x squared minus 9. How's that going to factor every time? X
X
plus,
plus 3.
it will always go back to x squared minus 9. So our middle terms, there's a positive 3x and a negative 3x. So we're just making it that way. Why did they say we might make it that way intentionally? Because do you know what 1 minus sine squared is? What's 1 minus sine squared x?
Wait.
Cosine squared.
It's simply cosine squared x.
Oh, really?
So this is really 1 plus sine x over cosine squared x. And if it's something said, just simplify this. This is what we would go to. So there's nothing else to do with it. Okay, but I'm going to simplify it as much as I can. I have one fraction. There is a caution box that we're going to look at on the bottom of page 207. Verifying identities is not the same as solving equations.
Okay, yeah, that's what I was saying.
Yes. Techniques can be used in solving equations, such as adding the same terms to both sides or multiplying both sides by the same term, should not be used when working with identities when you're starting with a statement to be verified. That may not be true. I will say, the question's always asked, are you going to give us something to verify that's not true? I won't. Every one that I give you will be true. Will be true. So every left side will equal the right side, even when you think it won't. So that kid's like, yeah. Well, I mean, it was the other class. It was like, I feel like it was like 2 weeks ago. I don't remember. They're like, oh, this one won't work, and they just gave up.
Whoa!
I said, I told you I would not give you one. It doesn't work.
At least you could do is put an arrow and put check mark.
No, you get no credit for that. You get no credit for that. This whole thing is I must see your steps. So we're going to start with 1 in the book.
Okay.
Verify the following equation.
Verify.
Cotangent theta plus 1 equals cosecant theta times cosine theta plus sine theta.
Well, Miss Ellen, you could have started off easy.
This is easy.
This is easy.
Oh, well, actually, the last one that we did was easy.
Yeah, that was easy.
That one was very. Now we some that are different.
No one shared anything yet.
Yeah.
No, nothing.
Okay. Nothing.
Yeah.
Well, I kind of feel like maybe.
Nothing. Worst thing to do is to give people answers before they even have a chance to solve them. So people just work slower than others.
And I will say the book. Oh my gosh.
This Evans, you need this paper.
Stop. Then you get up and hand him one.
Dude, it's snowing.
Really?
I didn't notice that the first 12 times that I looked outside in this class period.
It's kind of coming down, but oh well.
Hung down earlier.
Let's work.
My thing
You
is
need
figuring out which side's.
Which side is more complicated?
Did you ever
Right
watch
side,
the
right
video?
side.
I think, yeah.
Yeah.
Okay. I don't know what you just said. I'm talking about this problem. So, there are multiple ways to do each problem. Okay? Not everybody is going to start and go the same exact direction on every problem, including myself.
What? Listen, I'm so confused.
Rewrite in terms of sine and cosine. And then when something is on the outside of parentheses, what should you do with it?
Multiply by 1, multiply.
Distribute. What did you
Undo.
Okay, what did you rewrite it as?
I divided
Nothing.
it.
I don't know what you're talking about rewriting.
Okay, you want in terms of sine and cosine. So
So
on the right side, maybe you have to decide what side am I going to work with?
So make
would you
cosecant.
Well, I divided
you
by
distribute?
cosecant.
How?
Like I just divided it to get it on the left side.
You cannot do like you're solving equations. Okay? We will not just divide both sides by something. Okay? You're going to take one side and you're only going to work with one side. Okay? So on the right side, I think it's probably more complicated. So, can I rewrite cosecant theta in terms of sine or cosine?
Yes.
1 over sine.
It's 1 over sine, yes?
yes.
So I'm going to literally rewrite this problem. Okay? Writing all the steps is huge. Okay? Now, have you written that down? That second line. Okay. So now, when you distribute, what happens? Wait. I'm doing my
The
arrows.
sine crosses out.
No. Oh, wait, pause.
How do you even distribute that?
What's 1 divided by sine times cosine over 1? It's a fraction
Sine
times
theta
another
over
fraction.
sine theta.
So you multiply the top. What's
Cosine
1
theta
times
over sine
cosine is cosine. What's sine theta times 1? Over sine. Okay? Plus, what's my next one? What's 1 times sine?
1.
No.
Sine over theta.
I want to see this.
Oh.
The steps are important. And then sine theta times 1 is sine theta.
So 1.
Look, what's sine theta over sine theta?
Oh.
It's
oh,
all 1.
Oh.
What's
oh.
another way to see
Fine.
What's another way to see cosine over sine? Do you see it?
Cosine. What?
I found it. Actually, cotangent
Oh,
equals
yeah,
cosine
cotangent.
theta over sine theta.
Okay.
So then
Okay.
they equal each other.
They equal each other. But all of these steps are important. That's what I'm going to check. And I take this, I take that, they equal, I have a check mark.
Okay.
Okay, let's do another
It
one.
makes a little bit more sense. See, you can't do the first one all by yourself.
Yeah.
This is how it works. Okay?
I think with time I could figure it out.
I think with time, and now this one you'll be able to do a lot easier. And I kind of get away from the book, because the book gives like 3 examples, which is not enough. And they get hard really quick. Cotangent x. Could I put x's or thetas? Does it matter?
No.
No, it doesn't matter. So cotangent x times secant x times sine x, does that equal 1? So now you have to make the determination which side is more complicated.
It's
The left.
cotangent x times secant x.
Yes, if you want me to put the
Okay.
dot. Or you can put them all in parentheses. Rewrite.
Is there just two quotient identities?
Mhm. What colors do you want? Add two there. This is your middle color, so they're all three of these are the same. So which one of those do you want? And then red is
White.
so now you only have to do one. What color do you want for the front one then?
Can you come look? See if I got it.
Do you have to multiply those in order as they're written?
No, what's multiplication?
Let me see what yours looks like.
No, we're not done yet. Not done yet.
I feel like I'm missing a step. Like I have no idea.
Okay, is this in terms of sine and cosine?
I don't know.
It's helpful if they're only in terms of sine and cosine. So when you have the choice of cotangent, do you want to rewrite it with tangent? Or do you want to rewrite it as a sine and cosine? Like this pink?
Okay, no, no. Whoops. I went too far.
And what's sine?
I don't
Keep going. What do you do when you multiply this?
Oh.
So did you mark out?
No, it's just that and then that and then that is one.
Okay, but that's not the way. So you put equal sign, but that to me says you stopped the left sign and you just said, hey, it's equal to that. That's fine. I want you to keep going
Oh,
down.
okay, I got
Show me where you cancel.
Is that
Is it this just really?
Yeah, what is sign? You've rewritten this one. You've rewritten this one. What's sign? You don't rewrite it. Sign it on the line.
Oh, okay.
And then you start multiplying.
Like that?
Question.
I'm lost.
Okay, well, can we? What is your cotangent as?
Cosine theta over sine theta.
No, what's secant?
1 over cosine theta.
And then sine.
1 over sine theta.
Sine theta is not equal 1 over sine theta.
Sine.
Over.
Sine.
One.
Sine theta. What is sine theta
So you
equal?
got
Yeah.
Oh, so
They
that-
have
There is no sine theta equals.
It's itself. Sine theta equals sine theta. You
you
don't have.
change sine theta.
You know
If
what
it's-
sine theta?
if it-
I got it.
You know, it's sine theta.
So cotangent theta. What did you have? What did you write it in terms of?
Cosine theta.
Cosine theta or x
Got it?
over sine x. That's your cotangent. What about secant? 1 over cosine x. What about sine? If it's already in terms of sine or cosine, don't rewrite it.
One.
It is simply sine x. If you want to put it over 1, that's great. Okay? But there should be a line here, and there should never be equal signs. We can put a line through the equal sign, don't write them. Okay? Now, if you want to stop right here, if you want to multiply it, cosine times 1 times sine is cosine times sine. Bottom sine times cosine times 1 is cosine times sine. Or I want to see where you've marked them out.
I could have done that.
It's okay. Because cosine divided by cosine is 1. Sine divided by sine is 1. So what do we have left? 1. Does 1 equal 1? Yes. Okay?
No.
Don't make it more complicated than it has to be. Okay?
There's not even any kids outside, and it's all wet and nasty. If there's no kids, I don't know.
Okay. Alright, what about this one? Cosecant x minus cosecant x cosine squared x is that equal sine x. Which side is more complicated? Definitely the left.
Is it? So
Now- Several things you can do here.
well, for just like separating it,
Okay.
is it cosecant x minus or like?
Cosecant x minus cosecant x times cosine.
So
Okay.
could
Go ahead.
I do cosecant x in parentheses and then negative cosecant x in parentheses?
Yeah, I mean, you can add parentheses. But hey, thank you for bringing that up. Because what do you recognize about both of these factors? Both of these terms,
They're the same thing.
do
Oh,
they
just
share a
cancel out.
factor?
They have the same factor.
So what can we do with that factor?
Cancel out.
Not
No,
quite.
because
But
they're
you
not-
can.
You just subtract them and then zero.
No, you can't because you gotta do multiplication first.
2 minus 2 times 5.
Oh, true. You're right.
Is that just 5? 2 minus 10 is different. Right? But what can you do with that 2? Okay, thought bubble going on now. 2, okay, just because my kid's doing this in algebra 2, 2x minus 4x. Is there something you can factor out? Do they have common?
Oh, 2x.
Technically, they have 2x, and then what do you do? 1 minus 2. Okay.
Okay, well, but
Do they share a common factor?
Cosecant x.
Cosecant x. So can we factor it out?
Yeah.
What does it happen? Cosecant x parentheses. When you
One.
factor it out, what's left?
1
1.
minus 1.
What's this whole
Minus-
factor?
Oh, minus.
Cosine squared x.
Okay, there's this line. We're only talking about the left side right now. Have we seen something like that before? Is there anything up there that you recognize? Hold it for just a second. Look. Look and see. What do you recognize?
Is it?
I found the 1 plus cosine. Oh, sorry, no, I was thinking 1 plus cosine squared.
So you're in a Pythagorean identity. They're squares. That's a great place to be. But where's one with a cosine square?
Cosine squared.
So does sine squared equal 1 minus cosine squared? Rearranging that one, if you haven't noticed, they're going to do that a lot. So over in my thought bubble, there's a Pythagorean identity that says sine squared theta plus cosine squared theta equals 1.
yes.
Can you rearrange? Because right now I see 1 minus cosine squared. So I've got a 1 and I've got a cosine squared. So if I subtracted cosine squared from both sides, is that sine squared theta equals 1 minus cosine squared theta? So where you see 1 minus cosine squared.
Hold up, we're going very fast.
I'm sorry.
I
How'd you
don't
get sine squared theta?
see.
This is an identity. We started with a Pythagorean identity that's on the back of your plate.
I know, but the sign on the right isn't squared.
We are not looking at the right side of the board at all.
Oh.
We are looking right here and right here only.
You divide.
Only. Okay? I'm just rewriting one thing.
So that
So
equals.
this right here that's underlined,
Oh,
1
no,
minus
no.
cosine squared equals what? Sine squared x. But could we
Oh.
rewrite cosecant x?
1 over
sine.
sine.
What is 1 over sine x
Uh,
times sine squared x over 1?
sine.
So what cancels?
The square.
There's a squared. It was really sine x times sine x, right? One of them cancels. This becomes 1. What are we left with? Sine x. Does that equal the right side? Check mark.
This
What
gonna
about
take
the
a few
square?
classes.
We are gonna work with it for probably the rest.
What did you say about the square?
Hey, really? What's sine squared x? We could have
Oh, it's
rewritten
just-
that as sine x times sine x.
Okay.
And one of them cancels.
Less.
Okay, so
and
one
then
of
you
these.
just gave one of them down. Okay.
So I just usually mark out the 2, the squared, to mark out one of the signs.
Thanks.
You're welcome. We will do this for a while.
Good.